Hello, we are the Group 8 and here we are about to present Unit 13, the crust. This is the general characteristics of crust. The crust is the outermost layer of Earth and is the only layer where organisms are found. This layer makes up less than 1% of Earth's total volume. This rigid layer is in the constant process of destruction and renewal, wherein new crust is formed in oceanic ridges, while some are subducted through the mantle. One of the parts of Earth's tectonic plates is the crust. Tectonic plates are slabs of the brittle lithosphere, which can be able to move due to the plasticity of the underlying asthenosphere. Most of the seismic activities, including earthquakes, happen near the boundaries of these plates. The crust is divided into two parts, the continental crust and the oceanic crust. Now for the continental crust. The continental crust makes up the land surface of Earth, which is about 32 km thick but may reach up to 70 km in mountainous areas. The composition is more variable than oceanic crust but can be generalized as mostly granites.
Mountain belts are uplifted regions of deformed rocks. These are formed during orogenesis or mountain building belts. An example of a mountain belt is the Himalayas that was formed by the collision of the Indian plate with the Eurasian plate. Interestingly, the highest peak of this mountain range is the Mountain Everest. So the mountain belt is a group of mountain ranges with a similarity in form, structure, and alignment that have arisen from the same cause, usually an orogeny.
While the stable interiors are older than mountain belts, within these areas are expansive and flat regions which are composed of deformed crystalline rocks, called shields. In some cases, areas of the stable interior with deformed rocks are covered within layer of sedimentary rocks which are called stable platforms. And now the next is oceanic crust. The oceanic crust is a thin layer averaging from 5 to 7 km thick. It consists of mafic rocks, which are made up of silicates, magnesium, and iron. An example of mafic rock is basalt.
Basalts. Basalts are rocks composed mainly of calcite plagioclase and pyroxenes, minerals that are usually dark in color. So the basalts is an apenitic extrusive igneous rock formed from the rapid cooling of low viscosity.
Our next topic is continental margins. Continental margins are the areas which separate continental and oceanic crust. It includes continental shelf, continental slope, and continental rise. The continental shelf refers to the gently sloping platform extending seaward from the shore. These are flooded extensions of the continents. The continental slope is the area where the boundary between continent and ocean basin lies. It is a region where the angle of descent becomes steeper and reaches up to 4 km in depth. The continental rise is a gradual incline in regions where trenches do not exist. Here, as shown in the picture, are parts of continental margin. You can see the coast is beside the continental shelf, while the continental shelf has a continental slope and it has a continental rise.
So meanwhile, deep ocean basins lie between continental margins and oceanic ridges. Sea mounts and abyssal plains are found in these regions. On the other hand, oceanic ridges are composed of layers of igneous rocks that have been uplifted. These are the site of formation of new oceanic crust.
So here are our key points. So I want you guys to remember that the crust is the outermost rocky layer of Earth, which is mainly composed of granitic and basaltic igneous rocks. It can be classified as continental crust or oceanic crust. And the other one is continental crust is composed of granite, wherein it can either be in the form of mountain belts or stable interior.
Key points. Oceanic crusts are composed of basaltic rocks and is denser than continental. There are three parts of oceanic crust, namely continental margin, deep ocean basin, and oceanic ridge. Lithosphere makes up the tectonic plates, which is composed of the crust and the uppermost mantle.